Let me start recording. Okay, so let's do the measure again. So what we've done in this tutorial basically is to rasterize, and we are now trying to combine, two rasters, for which if you look at the lake, when you look at the lake raster. So lake, river, you see, the two are quite separated. Okay, these areas are 0. That's the point we are seeing. These areas are 0. So lake 0. This is 1. Okay, select the river. So these are also zeros. Okay. Right, and then we did a measure. So after the measure, we'll check again. Let's just merge the two by simply adding lake plus river, and we put it somewhere and call it water raster, as we did. Water, let's go raster, and then save. Okay. Right, so now we have one layer. We switch off the lake and then the river raster, and then we check values here. They are all zeros. You see, probably it's not necessary, but if you really want to get into it and test the system, then there should be a way to say that any value greater than 0. Okay, does it make sense? Let's go back to our tutorial. There's a point that was being made there, which is very important. I want us to really understand that from that point of view. That okay, so 13, enter the following expression which will assign the value 1 that matches the expression, and 0 where it doesn't. Okay, so where the expression is raster water and the value is greater than 0, which means if it's 1, then we get 1. So that's like just keeping the same thing. Okay, so we're gonna, because of the weird results you got, I don't want us to repeat it. It's not necessary if you don't have to. So let's leave it for now. The resulting raster water now has pixels with only zeros and ones. Later I'll find out why we got all the noise that we got in there. But I nearly said verse 15. Anyway, I'm coming from church. Okay, so step 15, procedure. In the procedure, now that we have layers representing road and raster or rivers and water pixels, we can generate proximity rasters. Okay, so proximity. What is proximity? Proximity is how close or how far you are from a particular place. That's proximity. So from this new raster layer, we should be able to tell that, okay, you are this far from these objects. So when we take the pine tree, for example, when we generate a proximity raster for the pine tree, we should be able to get how close or far we are. Okay, from the a pine tree, we'll get a new raster that's able to do that. As to how the computer does that, of course, we can just imagine how it does that. Okay, so where I am now, I'm very close to water. The Wager Lake is here, and the sea is also right there. So you can ask yourself how close you are. That will determine the proximity of the raster. Okay, so see, these are also known as the Euclidean distances, of course, where each pixel in the output raster represents the distance to the nearest pixel in the input raster. Okay, so what is my distance from a pine tree? We are going to generate a raster like that. Or what's my distance to a river, a water body? We are going to generate something like that. The resulting raster can then be used to determine the suitable area. So then we are just one step away, then we say goodbye. Okay, then I give you some tips on the exam. Well, tips, I don't even know. Why do I like making promises? Okay, so we go for proximity, raster distance dialog. Let's go for proximity. To find proximity, let's go to the processing tool. So I'm going to show you, if you are using QGIS, the latest version, excuse me, simply look for the processing toolbox, which always appears on the right hand side, okay? And then you simply search for, you type in proximity. There's a box there, proximity. Okay, so proximity or raster distance. You click that, then you get a dialog box. Okay, so processing toolbox and then proximity. Processing toolbox and then proximity. Processing toolbox and proximity. Okay, get a dialog box and then you fill it. Is that okay? Get a dialog box. Which one do we want to turn into a proximity map? Literally, this is what we're going to happen. We just choose a water raster. Then we go for the distance units to reference coordinates. Then the maximum distance, we can choose 5,000. Okay, which says that, okay, if I'm actually trying to look for areas of interest, okay, areas that we should work out these values for. Okay, in terms of proximity, what should be the maximum distance that should be generated? We are saying 5,000. Doesn't make sense. Is it practical to say that? Let's just pick our measure tool. So go up there, you find a measure tool, and then look at the distances. Are you okay? So you can just click a point and go all the way. You know, for every point, what's the largest distance you can be away from, you know, any other point within the region? I don't know, the way I'm putting it doesn't sound right, but we just want to actually tell the computer that if you are looking at how close things are, then go this far. That's the maximum distance. Are you okay? That I want the computer to generate. Okay, so it's able to generate quite a large distance. So here I have 29,000, okay, 15,000 meters. Okay, so that's quite a huge distance, isn't it? All right, so let's do, say, 24,000. Let's see what the result is. I mean, it's better to just give it a go. 24,000. Let's see the result. 24. Even though for the tutorial, it's used a certain value. Are you okay? But we don't have to necessarily stick with his values, but the data we are using is different. Okay, so he used 5 kilometers. We are using like 20 kilometers. That's quite a distance, isn't it? 20, 29, 24 kilometers. That's quite a large distance. But let's just see how it goes. Okay, we need to choose the georeference coordinates, which is in meters. Okay, so we have to write 24,000 meters. Okay, then no data set. So the value to be applied to all cells that are within the maximum distance of type, that should be 0, and then no data value should be not set. Okay, so it's very important that we keep this one 0 and keep this one not set. So you know how to do that. There's this cross symbol here. Go for that. The next thing you do, so this tutorial I've sent it to you, so you know. You can just, you know, follow it. You don't have to look at, I don't have to display it on the screen. Okay, let's run it and see what we get. You know, so we're getting something. It looks nice to me, not bad. It's looking like something good. I like realistic stuff. Looks realistic. So this is the water proximity. Are you okay? So we're going to save it. And I'm going to explain to you what it represents. I think you know what it represents, but I'm going to still, so let's call it water proximity. It will tell us how close we are from water. So save. So you are the engineer, don't get emotional, okay? Get someone to do the analysis for you if you know this is not your area, but know exactly what is required to locate something. You need to understand distances and locations. All right, so pick your identify features tool, and let's be clicking around, selecting the water proximity layer. We can remove the proximity map, which is a name that a computer generated. All right, so we will be clicking around to see what's going on. So here, where I just clicked, I am about 1,000 meters from a water source. Okay, 2,000. Okay, so the values are actually okay. So these are pine trees. These are pine trees. So to see the actual effect, you put in the water. So let's put on the river layer. So the farther away we get from the river, the larger the values become. Okay, the closer we get to it, we are getting close to the water body, so it reduces. Okay, beautiful. This is just enough for someone to say, okay, we'll keep you for another year. Instead of, okay, we called you because we have found you wanted. So this is the value that we are looking at down here. Okay, it's changing. Hey, what's going on? It's changing. Okay, according to how close we are to the river. Let's put on the lake. So the closer we are to the lake, the higher the values. Okay, isn't that beautiful? No, the smaller the value. Sorry, proximity. So we are getting closer and closer. Are you okay? So we are in the lake. So now 0. Are you getting that? Now here we are too far. All right. So that's the beauty of working out a proximity raster. Let's say proximity map. All right. And so it's raster, not vector. Now the lake is vector. The river is vector. All right. So the next thing we need to do is to follow the tutorial religiously and see what else we have to do. The next we need to do is just do the same thing, proximity for the other vectors. So pine tree, we'll do pine tree, then we'll do, what's the other one? We done river and lake have been combined. So we are only left with the pine tree, isn't it? Okay, so, okay, let's do that. Let's do pine tree. And we have the DEM, but we'll talk about the DEM. Soon we'll talk about the DEM. So pine tree, georeference coordinates, 24,000, proximity, value to be applied to all cells that are within 0. So that's why we're having zeros inside the lake, because we set it, isn't it? Without put anything there. Then no data value, put not set. Then we say run. So that one should also give us something nice. And so obviously it makes sense. When you look at it, you can definitely see that these are actually proximity. Are you okay? In other words, if you wanted to go on a certain path in between, okay, these features, you'll be just going like so that maybe you are avoiding these 3 things. Are you okay? So if you're constructing a road, even then, and you wanted it not to be too close, these are the optimal paths that you use. Are you okay? Right. So this is it. We're getting somewhere. It's getting excited. It's getting nicer. Our boundary is still there, waiting for us to, use it as and when we need to. Okay, so now we are going to do raster algebra. I think that's naturally the next step. So there you go. We've done the water. We've done the pine tree, and we have a DEM. Okay, so beautiful. Let's look at step 9. You see how far we've gone. We never thought we'd get this far. but we made it. Once the processing finishes, you can apply the similar styling as for visualize. Okay, so what he means by visualizing the result is actually going back to QGIS. Oh, I'm still in QGIS, sorry. But I'm just referring to this, that to see it the way it's looking like here, where there seem to be different values, there's a change in values. I think you could just, you know, change it in your properties. You can style it. Are you okay? So let's not waste our time on styling. We are engineers. Are you okay? We don't have time for style. Of course we do. I'm just kidding. So we are going back to the raster calculator, and we are going to write expressions that will now bring the multifactorial or multi-criteria selection process. Now we need to establish what the criteria is. Okay, so one of the criteria, what's the plural for criteria? Criterion. One of the criteria, and I hope I got it right, is for YouTube anyway, is to look at the whole data set again and to think through it. Okay, so let's go for that. How this was done. Look at, let's try to understand this. We want to give higher score to pixels that are near to roads. Are you okay? So we are doing what we call reclassifying. Are you okay? In other words, we are going to put all our layers on the same scale. And once we put all our layers on the same scale, then we are going to do an addition, bring them all together. Then we can say, okay, there seem to be more of what we are looking for. Like areas seem to have a higher value, combined value. Are you okay? So then that becomes the multi-criteria. So the raster calculator uses interesting expressions that I think I need. No, I think I have to explain so that we understand. Let's look at this one. So what is this statement saying? It's saying that take your roads layer, proximity. What do we want? Pixels that are near to roads, we're giving it higher values, higher values. So we are saying that 0 to 1,000, 100. Okay. Now, 1,000 to 5,000, giving it 50. Okay. Then greater than, so if you are far from the road, you get a higher score. Take off your mic, Ruben. Ruben, be careful, okay? Do you hear me? You're not listening to the lecture. Your mic is on. You are just disturbing the class. Huh? And unfortunately, I can't even mute. Let me see. Everything shows you're not even in the class. Okay, anyway. So we're saying that give a score of 100. So 100 for distances that are closer. Are you okay? Then as the distances get farther, reduce the score. This is a basic explanation to multi-criteria analysis. It's mathematical. Are you okay? So look at this expression here. 100, okay? This expression is very interesting. Look at it again. When I take my proximity map and I find out that a value is less than 1,000, okay, multiply it by 100. That's interesting, isn't it? So proximity map less than that. So let me tell you what is happening here. This is what we call the logical expression. In every logical expression, the result of the evaluation is true or false, also 0 or 1. Now, so to satisfy distances which are less than 1,000, if you satisfy that condition, true means 1. Now, if you get 1, then as your result, then 1 times 100 is what? 100. Now, what have you done? You've now, it means you have assigned 100 to that particular pixel. I mean, this one is something you need to, listen to again and again. I'm recording this, so when you get a video, play this part again and try to understand. So it is actually a comparison which results in 0 for false, and then 1 for true, and then the true value, which is 1 times 100, then becomes 100. So the result of the expression we see here, if the value is less than 100, is less than 1,000, it's actually 100. So you end up assigning 100 to 0 to 1,000. So we can actually copy this and apply it to our data sets. Are you okay? So rows, we are going to write this long expression for it. We can write our own expression. So let's look at our data. For our data set, 24,000 seem to be the range, or let me just say 12,000 seem to be a realistic distance. So let's go back to our QGIS and try to, now I don't say QGIS anymore, I say QGIS. So let's take our ruler, which is up there. You see a ruler symbol up there, and let's start measuring that. How would we want to, measure the distance? So if we are this close, what distance is that? 3,000. Are you okay? So that is, okay, let me cancel it. Let's try it again. So if I do this, this is 4,000. That's 11,000. Yeah. 14,000. Okay. Yeah. So these are our values are in that range of 4,000. Like in the thousands. So 2,000, 4,000. Just for the tutorial, let's just put in some values. So we are going to design a scheme like the one we have. So I'm just going to do it like so. I'm simply going to copy the formula, put in our layers, and then we are just going to vary the values and see what happens. So let's go for the raster calculator. So raster calculator, and then this is the expression we want to edit. Is that okay? So I'm going to just do this. I'm going to highlight water proximity at 1, all this. Okay, what I did was I copied everything, then I simply did find and replace. That also works. But let's do this. This is better for the tutorial. I just highlight the value, then I click on, this is for roads. So let's use the same criteria. So let's treat, which one should we treat like this? We don't have roads. So let's go for the water proximity. Okay, let's do it for the water proximity. So water proximity, then we have the, we come to that. So water raster, water proximity. Remember, water raster and water proximity are the same. Okay, so you can see that I've replaced it down there. If you can see it, what I do is that I copy from the double quotation, I highlight from the beginning to the end, then I double click on water proximity, then it replaces it. Okay. So on a scale of 0 to 10, or is it 0 to 100? Yeah, exactly. I'm simply, just that will change the distances. The distances being used here fits the data set that is being used. So I'm replacing, so I'm using a formula, an existing formula, water proximity, water proximity. So I have water proximity throughout. Okay, and I understand the formula. So here, this is where we want to find a range of values between 1,000 and 5,000. This expression, if you want further explanation, I think you can get it, but I think this is how best we can do it. The distances are 1,000. We are going to start from 4,000, 3,000. Okay, then 3,000 to say 10,000. Then anything above 10,000. Are you okay? So here we want to be close to the road, okay, to the water body. So it's an irrigation project. So 10,000, 10,000, 3,000 to 10,000, less than 3,000. So this expression should work, and let's try and put it in there somewhere. So we are going to save it. Excuse me. And we are not going to call it the reclassification for our water. Okay, so water reclass. So I'm saving it as water underscore reclass. So reclassification is grouping cells. I've talked about it. The videos are there on YouTube. Anybody who is hearing this for the first time, you may fail. I'm sorry. Sometimes we have to be hard. So water reclass, save to the DM. All right, and then we just say okay. All right, so that's a nice one. I don't know how nice it is, but yes, we have something that shows how far we are and from the water body. So it's been classified, okay, into how many classes? 1. So let's take the I. This is 100, means we are very close. 50 means we are in the middle. Then 10 means we are the other end. Let's look at the tutorial. It was, yes, that's exactly how it was done. Great. So now we've gotten that. That's step 20. So let's look at the tutorial again. So in step 20, we've done this. Is that okay? And we are going to go to step 21. So once the reclassification process finishes, a new layer is created. Okay, and I think we understand what it means. Okay, we have grouped the cells into different classes as we do in statistics. You know, we're able to group data, right? That's what we've done. We can do the same thing for, we just did water. We want to do what again? The pine tree. Okay, so we want to be farther away from the pine tree. What will be our criteria? So let's go to the raster calculator. And we've already used a formula. So let's see if we can actually write this one ourselves. Excuse me. Let's not waste time. Copy an existing formula and then we just tweak it. So we are going to reverse it in this case. It's just like the one in the tutorial. So at step 22, just copy this. Ruben has come up back again. Ruben, you like a former lecturer of mine said, I've marked your forehead. You are disturbing me, my peace. It's not funny anymore. We are recording this thing for YouTube. You can't do what you're doing. So I'm replacing this with pine tree. Okay, then we'll adjust the values. It will reverse it. So if we are far from a pine tree, we prefer that. So let's see what happens. So I just do pine tree. We haven't done pine tree proximity. That's the only challenge. Are you okay? So let's do pine tree. We have pine tree raster, but we don't have pine tree proximity. Sorry about that. So let's quickly do pine tree proximity. So pick pine tree raster. Or maybe we did it, but we didn't save it. I don't know. But I think we did it, yeah. Remember we did it. They were just some round things. So let's switch off all layers and hopefully we'll be left with. Yeah, that's it. So let's save this as pine tree reclass. No, pine tree proximity. Okay, export pine tree proximity. So pine tree underscore proximity. That's how I'm saving it. We have 10 minutes. Guys, the rest is for you. Is that okay? We are done. Honestly, I should just carry on. Just watch the rest going and please try it yourselves. It's very important. So I'm just gonna not talk much now. Just gonna carry on. Pine tree proximity. I'm going to do the reclassification using my raster calculator. Raster calculator has been used twice. I think I just copied this one. So now when I see water, I want to see pine tree there. So pine tree proximity. So I've intentionally left that one. I'll come back for it. Pine tree proximity. Pine tree proximity. So everywhere I have water should now be pine tree. And then so now, so anything less than 1,000 through 1 times 10 is equal to 10. Then that makes the assignment. So now it's pine, pine, pine everywhere. Okay, now let's change our values. It's from 1,000 to 5,000, 50. Oh no, hold on. The assignment is 50, 10, 100, but the values is 10. No. Okay, so 1,000 is the minimum distance, which we said 4,000. What did you say? 3,000. We did say 3,000. Then we went for 10,000, 5,000. Am I getting this right? 10,000 and anything above 10,000. Yes, that's right. Okay. Okay, so we have to be careful. If the logic doesn't work, you end up with something funny, honestly. You wouldn't like it. So between 5,000 and 10,000, that's between 10,000, no, 3,000 and 10,000. Wow, I got to do this well. Pine tree less than that. Pine tree in between 1,000 and that. Okay, between 3,000 and 10,000. Then the last
previous one, the first two were 3,000 and the last two were 10,000.
10,000. Okay, so 10,000. So 3,000 to 10,000. Anything above 10,000. Is that all right? Yeah. Yes. You were saying something. Is that not correct? 3,000 to 10,000. Anything above 10,000. That also right? Okay. You mind me, but you are just talking right now. So this is for the pine tree reclass. Okay, so pine tree reclass. Say okay. All right, so reclassification is looking more like some buffering, isn't it? It's a buffer. Literally, it's a buffer. It's interesting. Okay. So this is what we have. Okay, so it's fitting into the bounds. All right. Wait. So literally, what we are doing is that we want to just combine. What you do is that you just add them up. Okay. After you're done. So the DEM2, you can write another condition that says that every slope, every height value above a certain level. So you can just go into your QGIS and do that. And raster calculator. So raster calculator.